and this is surgical medic on your screen. So we want to deal with calculations under the 4 quantum number. And this aspect of chemistry, I found out that 90% or let's say 99% students are finding this aspect of chemistry very difficult. So, but then you would understand this in such a way that you will never forget again. So let's go to the study. Quantum, what's quantum numbers? Alright, so now let's understand what these quantum numbers are. So the very first thing, I think the mnemonic I used to code this thing into my memory in such a way that I'll never forget again is the palms. That's palms. P-A-M-S. Palms. So this 1, 2, 3, 4 here are the 4 what? Quantum numbers. The 4 quantum. So now here, this is our P, this is our A, our M, and S coming from what? Palms. So P here is what? The principal, which is giving us what? N. So this is the alphabet we use to that correspond to principal, that we use to denote principal. Now azimuthal, your azimuthal quantum number is giving us what? L. So this is the alphabet that you would use in place of azimuthal, or that we can use to represent azimuthal. This is your magnetic, and it's represented using what? M of L. M of what? Of L. Then the spin here now, the spin is giving us what? Yes. So these are the 4 quantum numbers. Now let's understand them one after the other. So the principal here is actually describing, the main energy level. This one is describing the what? Main energy level. So the principal and azimuthal, they are describing the energy levels, but the principal is describing the main energy level, while the azimuthal would now describe the energy sub-levels. Sure you get the energy sub-levels. Now let's go back to principal again. The principal is describing the main energy level, and as well it will describe the size. You get the size of the orbitals. So if they ask you what is describing the size of the orbitals, it's simply the principal. Sure, it's simply the principal. So that's about the principal, and you should know that this principal corresponds to this alphabet, our K, L, M, N, O, P, stop. So K, L, M, N, O is just telling you, your number of shells. So the principal corresponds to the K, L, M, N of O, in which your K is what? 1. Your L is what? 2. Check it. Your M is what? 3. Your N is what? 4. Then 5. Meaning that this one is just one shell, just a single shell. Your L is 2 shell. Then your M, 3 shell. Your N, how many shell? 4. Then your O, how many shell? 5. So that's the principal for you. It's telling you the main energy level. It's describing the main energy level, and as well as the size of the orbitals. As well as the size of the orbitals. Then the azimuthal here. The azimuthal here is actually telling you about the energy sub level. Please don't mistake azimuthal for principal. Maybe if you are talking about energy level, go and look for something like the main energy level. So if they are talking about main energy level, go and look for principal. But when they are talking about sub levels, please go and check azimuthal under the option. So azimuthal is describing the sublevels, and it's actually talking about, like, it's also describing the shape of these orbitals. Let me clean this part so that we can I would have this thing to express myself very very well. All right, so now let's look at these sublevels very well. Or let's now, this one is actually determining the size of the orbitals, right? Then the azimuthal would now determine the what? The shape. The shape. This one is determining the size, please don't forget. But this one is like describing the shape. So the shape, whether the shape is spherical, whether the shape is dumbbell, sure you get. So this azimuthal is one that will help us describe the shape of this thing. Now, so that's bringing our this thing to our SPD of F. Are you with me? SPDF. So your S is just telling you that the S is what? Spherical. Then the P is what? Dumbbell. Alright. Then your D is what? Double dumbbell, and so on. So let's clean this board again. Then we move to our magnetic. Hope you guys are getting this thing. So under principle, we're talking about how our size of the orbital, which is the KLMNO shell. Then now we discussed about azimuthal. Alright, azimuthal. And azimuthal is what? Describing your energy sublevel and the shape of these orbitals. Alright, that's azimuthal for you. And don't forget, when I was explaining principal, and principal is telling you about the number of shell now, your K, L, M, N, O. Share you get. Then principal is just telling you that, okay, maybe our number of shell, you get our number of shell. So the number of shell of K shell is 1. You get. The number of shell of L is what? 2. The number of shell of M is 3. The number of shell of N is 4. The number of shell of O is 5. Then for advanced level, we now have something like P, and the number of shell of P would be 6. But coming to azimuthal, azimuthal is telling you about the shape, whether it's spherical, whether it's dumbbell, you get. So S, P, D, F. This is your azimuthal. Please don't forget. I said something that this N is the letter that we use to represent our principal. Don't forget. Then this L here is one that helps us to do what? To represent our azimuthal. And azimuthal is the one describing the what? Energy sublevel, and as well as the shape of this orbital. So S is what? Our spherical. So P, dumbbell, double dumbbell, and so alright, that's for azimuthal. I think the next thing you guys should understand before we go into calculation is the magnetic. Alright, let's go there. Our magnetic, which is giving us our M of what? L. M of L. This is what we use to represent the magnetic. So now, this magnetic is just telling you about the degree of degeneracy. That's what magnetic is trying to tell you. So nothing much under magnetic actually. Magnetic, the formula for finding magnetic is your magnetic L, which is equals to your N minus what? 1. Are you with me? So if they say, okay, find the magnetic of the L shell. Your L shell now. Your L shell. They say, okay, find the magnetic of L shell. L shell is how many? The number of shell of L is what? The number of shell of L is 2. That means your N is what? 2. Alright, 2 minus what? 1. That means your magnetic is given as 2 minus 1, which is what? 2 minus 1 is what? 1. So that means your L shell is given as what? Magnetic of what? 1. So I think that's that about magnetic. Then what we really need under this magnetic, because when we enter into the calculation aspect, you need it. So please pay close attention. This thing is very, very simple. Sure you get. Now, what you would use to decode magnetic, if they're asking you that, okay, what is the magnetic of this one, what is the magnetic of this particular electron or something, what you would do is that just know that it's ranging from, your magnetic is ranging from the azimuth, your plus, your minus L to your plus L. Are you with me? So if you are looking for magnetic of anything, you have to know. If you don't know your azimuthal, you cannot get the magnetic. You cannot get the value of. So that means your magnetic is equals to from your minus of your azimuthal to your plus of what? Azimuthal. When we get to the calculation aspect, you understand this thing very well. So let's say your azimuthal is 2 now. That means the value of your ML would be minus of your azimuthal, because your azimuthal is 2, to what? Your plus of what? Azimuthal. Now, if you now want to arrange it, you now go and use your normal inequality. This thing that is coming from minus 2, and we are going to 0. Sure you get to what? Your plus 1 and then plus 2. There is no need of you putting plus at the front. You already know that it's positive here, so you don't need to. So that means the magnetic here is what? Ranging from minus 2 to plus 2. I don't know if you get. I think you should be able to do if L is 3 for me. This one is if L is 2 actually. If L is 2. Now let's do for if L is 3 now. If L is actually 3, we will have it as, you know, my magnetic is given as minus L to what? Plus L. Are you with me? So we are doing for if L is 3, that means our L is just 3 now. So just put it there. Minus 3 to what? Plus 3. Meaning that our magnetic is ranging from minus 3 down to the positive side. That's minus 3, minus 2. Sure you get. Then minus 1, then 0, 1, then 2 of what? I don't know if you guys are getting this thing. So when we get into the calculation aspect, that's when we would use all this thing. That's the magnetic. Then we have our spin. Let me clean the board. Spin, alright. Our spin is very, very simple. So let's try to reverse back and check if you guys understand. Have you understood? So determine the azimuthal quantum number of which shell should we use? Let's use of K shell. So now what will you do here? When they're asking you to find the azimuthal quantum number of K shell, and I gave you the formula now. So the very first thing, just your formula is what? L, which is equals to what? Your N minus what? 1. So, and this is your formula now. So then you say that determine the azimuthal. I told you azimuthal is given as L. Quantum number of the K shell. Now I told you shell. That's when you're having your K, your shell, K element O P Q R S. Now, so we want to know the number of what? Of shell. Number of shell of K is 1. Number of shell of L is 2. Number of shell of M is 3. Number of shell of N is 4. Number of shell of O is what? 5. Alright. And now we are looking for the azimuthal quantum number of the K shell. So the K shell is what? 1. Are you with me? The K shell now, your K shell now is 1. So that means your N is what? 1. So my 1 minus 1. That means the azimuthal number here is 0. Simple. That's the answer. Let's clean the board. Let's clean the board. Alright. So you can go to, what is it called? I think we should do something on the one we did last. That's magnetic. So find the magnetic quantum number. Find the magnetic quantum number of if azimuthal is 2. So I think we can do this one now. Find the magnetic quantum number if L is 2. This one is very simple. You know that your magnetic quantum number ranges from your minus azimuthal to plus azimuthal. Sure you get. So since you know that it's ranging from minus azimuthal to plus azimuthal, what is your azimuthal? What azimuthal did they give? They gave you 2 as the value of the azimuthal. That means it's ranging from minus 2 to plus 2, from your minus L to plus L. So that's your L is what, 2, and it's ranging from minus L to what, your plus L. So the value of L is 2. So minus 2 to plus 2. Then you begin to write from minus 2 down to the positive 2. So minus 2, then your minus 1, then you'll be playing with this now. 0, then 1, then 2. Simple. These things are very simple. So I think you guys, you understood very well. Let's go to spin. I think that's the third one. No, the last one. Sorry, the fourth one. So this spin, this one is very, very simple. It's actually telling us the direction of our electron, whether it's going up or it's coming down. So the direction of this electron, and if it is going up, that means it's positive. That's positive half. Then it's coming down, that's minus half. So the value of spin is always either plus, the both plus half and what, minus half. Just the direction of the electron. That's spin. Spin is not hard. I think spin is the easiest now. So I think from a theoretical explanation, we can move with the speed of light to the calculation aspect. And I believe you guys know the speed of light now. So don't let me distract us. You should know it now. So let's find the value. So let's go to the calculation aspect. Find the value of the 4 quantum number of the following. Alright, so now let's do for 3D, let's do for 4P, let's do for 3S, and then let's do for 3P. So I think you guys should, okay, I'll do for 3D, and I'll do for 3S. Then you guys will do for 4P and 3P. So you drop your answer in the comment section. So now, so we want to look for the value of the 4 quantum number of the following. What are we going to do? We know what we are looking for now. Normal. The 4 quantum number is our palms now. We are trying to look for palms. We are trying to look for palms. So let's take the first listing. So I'll be doing for 3D and 3S. Don't forget to. I'll do for 3D and 3S. You guys will do for the rest. So if I already did that, you'll be now 3D. Let me do for 3D. So 3D now. We want to look for the 4 quantum number. We want to look for our 4, 1, 2, 3, and 4. So this is the 4 quantum number that we are looking for 3D. So that's, we are looking for our principal, our azimuthal. We are looking for our magnetic and spin. All right, so don't forget this one is giving us our small n, our L, then our magnetic, our spin. All right, so and I told you, okay, let's take it one after the other. So for principal now, our principal is n. So if you are looking for principal, this is where you would find it. You would always find it at in your question. So that's even the simplest step, because you are looking at it like this. So your this one now is your principal, and this one is your azimuthal. Please follow this. It's very simple. Now, so everything you are looking at it like this. So for this one, your 4 is your principal. This one 3 is your principal. 3 here is your so this one here now, this is our principal. This is our azimuthal. Principal azimuthal, principal azimuthal, principal azimuthal, principal azimuthal. So for this particular question, our principal is what? You know it already. Our principal is 3. That one did not need any explanation. If they give you anything, that number that they are giving you is your principal. 3 what? So 3 is your principal. Very fast, let's move to our azimuthal. Azimuthal, this is our azimuthal. So and I told you that azimuthal is actually trying to tell you about the shape S, whether it's spherical, whether it's dumbbell, whether it's double dumbbell, and then your F, that's SPDF, and it ranges from 0, which is 0, 1, 2, 3. Sure you get. So don't forget, S is not starting from 1, no. Azimuthal is ranging from 0 to 3. 0 to 3. Are you with me? Now, so let's now try to check. So now I told you that D is our azimuthal. Now, how is D our azimuthal? D is telling us the shape. Sure you get. And this D that is the shape, this is it here. Let me use my second marker. This D here, this is it here. What number is falling under that D? Number falling under that D is 2. So that means my azimuthal is simply 2. That's my value. This is simple. That means if F is here, we will trace it to F here, and the F here is 3 here. That means that's my value. But what we are looking for is D. So and the shape of D falls under the number 2. And please don't forget, this SPDF is simply from 0 to 3. So just trace it and then you get your 2 azimuthal. Now, our magnetic, alright, our ML. So I told you that ML is very simple, ranging from what? Minus L to plus L. And your L is what? Azimuthal. You know your azimuthal, this is your azimuthal that you are just looking like this. Your azimuthal is here. You are looking at it. So that means minus 2, alright, to what? Your plus azimuthal, your plus 2. So you now begin to use it to play that from minus 2 to positive 2 now. I want to play minus 2, minus 1, 0, then 1, then 2. There's no W putting plus here. There's no, we already know that this is positive now. So this is my value for the magnetic quantum number. Then your spin is plus half, plus half and negative half. Sorry, negative. What am I even writing? Plus half and negative half, maybe, and negative half. So that's that about that. That's 3D. So I've solved for A. So I'll solve for C. Sure you get. So if I've solved for C, you do for this and this by yourself. You do for this and this by yourself. So alright, let's clean the board. Now let's do for our 3 years. So let's do for 3 years. This thing is simple now. So for quantum number pounds now. Okay, let's start again. P A M S. Our P is what? Our principal. Azimuthal. Even a toddler would understand this. So seriously, even a primary one student, if a primary one student watch this, there is no how you will not understand. So our P is given as N L of, so M of L, sign of spin. So I don't need to explain. You guys, if you don't understand this yet, go and stay with that video, replay and replay again. So principal, I told you now that any question they give to you, look at it. This one will give you your principal, while this one will give you your azimuthal. So what's your principal here? Your principal is 3 now. So yeah, your principal is 3. Are you with me? Then your azimuthal L, let's try to look for it. So that's your SRB. So that's my azimuthal from S, P, D, F, and it's ranging from 0 to 3. That's 0, 1, 2, 3. Mean that my S is 0, P is 1, D is 2, F is 3. Then the value of my azimuthal is S. So I will trace this S. Here to here. So my S here falls under 0. My azimuthal is 0. Hey, this thing is very simple. Then magnetic. Hey, is that's my, the formula is from minus azimuthal to plus azimuthal. So my, and the value of my azimuthal here is 0. Alright. Then my 0, that's from my minus 0 to plus 0. But is there anything like minus 0? It's not possible. There's not like plus 0. It's not anything. 0 is 0. You cannot just say and see there's negative 0. There is nothing. 0 is nothing. So my value of azimuthal is 0. My value of azimuthal is what? 0. Sure you get. Then my spin is just plus half again, minus half. So the value of the 4 quantum number is 3, 0, then 0, then our 1. That's from our plus half and negative. So this is my principal azimuthal magnetic spin. So I think, yeah, that's that. You guys should do for 4P and 3P. So those that are in the tutorial, that on WhatsApp, drop your answer immediately on WhatsApp. Let me meet it on WhatsApp. So that's that. Okay, see you guys in next class.